Good morning, everyone. I'm Joel Schlosser. This is some work my colleagues and I have done at Georgia Tech Research Institute for predicting conference paper acceptance in the 2016 KDD Cup. My colleagues are Erica Briscoe, Scott Appling, Trevor Goodyear, Jason Poovey, and Scott Brown. So by now I'm sure you guys are all familiar with the challenge to predict affiliation contribution at the 9 conferences, so I won't go into details on that. Just a little bit of background here. At Georgia Tech, we've done some research in similar related problems in the same domain, basically taking bibliometric scientometric methods, analyzing large amounts of data to identify indicators or patterns that point out maybe significant technological breakthroughs, innovations, innovative players, anomalies, etc. Interesting stuff you can gather from the data. So this is in very related domain. Often we would use clustering, co-authorship, co-citation analysis techniques. Some of which may apply here also. Some of the challenges we've run into is that scientific progress is often nonlinear. Advances in one field may promote or accelerate innovation in complementary areas, so we may have to look at papers in similarly unrelated fields as those fields come together to produce innovation. Also, there are many biases that exist here that affect how we have a solution here. Self-citation, institutional bias are just a couple of the possible biases here. Finally, exogenous factors such as a new publication venue coming forth may affect our models. For this particular problem, we're focusing on specific conferences, so this doesn't come into play. But for the more general problem of ranking affiliations, this needs to be considered. Just some related work real quick that we've studied here on patent analysis, innovation forecasting, and examining the use of culture and hot topics within for identifying innovations. Okay, so here's some potential approaches that we've first considered. First is analyzing the paper text and doing content analysis using NLP to determine relevancy of paper topic to the conference, and similarly doing an innovativeness classification on the text using semantic analysis. Both of these weren't really possible because we didn't have access to the full text available. There may have been a way to get that in an open way, but we didn't find that immediately accessible. Next, we could calculate innovativeness on the co-citation network. As mentioned before, it's often the case that contributions from disparate fields come together to produce innovation. So analyzing co-citation network may give indication on when that's happening. At the author level, we have the H-index, which is a metric that attempts to measure the productivity and citation impact of the publications of individual authors. And we can potentially use this to help predict the affiliations with which they're affiliated, information on that. Finally, we examined geographical distances between conference locations and affiliation locations, just to see if that had any impact on anything. So our overall approach was to model conference contribution as a regression problem, as many did before. Given some affiliation level feature vector, we want to predict the relevancy score as defined in the KDD Cup rules for an affiliation. So that's the output of our regression. For training, we have the feature vectors and ground truth scores from the conferences in previous years. This is all in the Microsoft Academic Graph data set. So we want to find optimal linear weights to best fit the training set data and then run that on feature vectors for the current year to produce our predictions. So here's the data set we used, the Microsoft Academic Graph. I'm sure you guys are all familiar with this. Citation information, publication information, where papers were accepted, etc., all that stuff. We also utilized Geographical Data data set called OpenStreetMap, and this we used to calculate the great circle distance between conference locations and affiliation locations. So this is an examination of the features that we used. We took a top-down approach to engineering features, tried a bunch of different things, and these are some of the ones we came up with here. Most naturally, at the affiliation level, we have the previous score, the previous relevance score as identified in the KDD Cup rules from previous years for each individual conference. As mentioned before, we also have the great circle distance between affiliation and conference. The intuition here is that there may be some correlation between if conferences are close by, maybe they're more accepted or affiliations contribute more to that. we weren't sure, so we included it to see what the results would be there. Another interesting feature that we looked at here was the sum of citations to that affiliation, to authors that are affiliated with that affiliation or institution in prior years. And the intuition behind this is to kind of measure that the impact that the affiliation had on the previous year's conference. So if a lot of people from the previous year are citing that affiliation, maybe they have some impact towards that conference, which would potentially increase their score as far as contributing papers. So finally, we have some author level features. We kind of took a two-pronged approach at first, trying to examine affiliation level features and author level features, seeing how we could combine the two. We brainstormed a bunch of features in both, and we wanted to take the best of both worlds here. So as mentioned before, the H-index of the author level, or the ratio of the author's conference accepted papers to their total papers for each conference, or overall conferences. So there's a bunch of possibilities here. So regression approach is, the natural approach is to take affiliation level feature vectors and use that to regress to the affiliation relevancy score. We can also take author level regression, use the author level features to predict author relevancy scores, aggregate those over the authors at an affiliation to produce the affiliation level score. We tried both of these approaches, and I'll get into some results on what we saw for that. As far as solving the actual regression, we examined linear regression and gradient boosted regression trees here. I'll cover the results later, but interestingly enough, we found that linear regression outperformed gradient boosted regression trees in nearly all cases with the small number of features we had. Some examination of our training pipeline here. We trained on the affiliation level feature vectors and the ground truth relevance scores, all of this gathered from the Microsoft Academic Graph. We trained on data from up to 10 years in the past and found that 4 years was ideal for giving the best results. And we validated this on the validation sets, which I'll cover briefly here. In order to kind of examine and compare our models, we came up with the validation set of predicting 2015 scores, and we also did a threefold cross-validation over data. And we examined both of these validation sets using these metrics. The score as defined in the KDD cup rules, we would actually calculate our final score and see what the scores between the models were, and we would calculate the mean squared error between actual and predicted relevant scores. So we used both of these to kind of compare our models throughout. One other interesting thing on training here, in order to kind of expand the training set, each feature vector is associated with a year in affiliation, and for example, Microsoft 2012 is a separate training instance from Microsoft 2013. Each feature vector uses data from one previous year only, so this kind of expanded our training set to use affiliations times the number of years that we had available. Like I said, we used 4 years, so that gave us a lot more training data. We also found that in training a single model for all conferences versus one model per conference, that model per conference definitely produced better results, so we went with that. So here's some of our test results. As I mentioned before, linear regression outperformed the gradient boosted. Interestingly, gradient boosted did beat out linear regression on 1 or 2 of the conferences consistently. So there's some differences between how the conferences, the people that contribute to those conferences affects how linear or gradient boosted works there. We also found that affiliation level features definitely predicted better than the aggregated author level features, so we use that overall. According to the linear regression coefficients that came out, the previous year's score was definitely the best predictor of an affiliation's relevancy score. The great circle distance was not correlated very strongly, and in fact had almost no relevance towards predicting. Finally, the number of citations received from accepted papers by an affiliation in the previous year, kind of complicated, that was somewhat correlated, and we did use that to some good extent here. So for the competition results, since they use SIG-IR to evaluate round 1, the linear regression model that we submitted for this was the previous year's score and distance as the features, just those 2 features, linear regression model using the training and validation that we identified before. We actually got first place in the first phase with a score of 0.8274. We then utilized a similar regression model, adding 1 or 2 features, moving forward in the next couple phases, and kind of just simplifying that stuff. And we did not fare as well in phase 2 and 3, earning 79th place and 93rd, respectively. So some conclusions on why that was the case. Even though we saw that regression was consistently valid on the validation sets for KDD and SIG-IR, we didn't perform as well in KDD as we did on SIG-IR. And this could be because other methods were improving as the competition went on. There's author level variation between who was accepted at the different conferences that we would need the ground truth to really dig into. And finally, the scoring system, the way that the ranking was done, it seemed very difficult to consistently produce a model that would score within the top 4 because there's some non-determinism there. So, yeah, that's it.
Questions? Yes. I have a question about the location features.
Okay, yes.
So, how did you evaluate the importance of the features of the location?
Yeah.
Is that important to your results, or it is not important? Did you evaluate in an offline way?
I'm sorry?
As a feature selection?
Oh yeah, feature selection, yes.
Yeah,
we
geographical
did
data is
do
important.
quite a few experiments onto which features to include, and we tried a bunch of different approaches and went with the best ones moving forward.
How do you define the address of the institution?
How do you
So
define
I think that there are several locations for each institution. So how do you define the institution's address? So you calculate the distance between the conference location and institution location. So I think there are several locations for each.
Right, the separate locations over, yeah. So we did normalize over the circumference of the Earth to kind of make that consistent across models, or across conferences.
Okay, thank you.
Can you give some detail on the great circle distance? Is this the geographic distance? Is the great circle distance you mentioned?
Yeah, so we use the OpenStreetMap to kind of pull the locations for the conference and the affiliation. We calculate great circle distance, and then we normalize that across the circumference of the Earth. That gives some 0 to 1 sort of metric that we can use as a feature value in our models.
Okay, it's a geographic distance.
Yeah, but it's a great circle distance. So yeah, yeah.
Yeah, I'm kind of intrigued by the use of the H index, and I'm wondering where you took it from and what it contributed to the overall result.
So unfortunately, the author level regression didn't perform as well as the affiliation level regression, so we didn't end up using the H index in our final submitted models, but it was a possible thing to expand upon in further research. So.
And were you calculating H index yourself based on the data in the?
We were using the Microsoft Academic Graph to do that.
Very good. Other questions? All right. Well, thank you very much.